Alright, so here is a real AP problem, and we're going to just, hopefully you've worked on it for a while. One thing you'll notice is they like to scare you. So they try to put like lots of scary things in it, and you start freaking out. And the big thing you have to learn is you just have to calm down. Like, they're not going to just be a one-step swag problem. So you have to just get used to seeing lots of different things put together. So they're talking about phosgene, which was one of the first poisonous gases ever used, and they're telling you how it's prepared, blah 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 blah, and it tells you where the name came from. That's great, but it doesn't, like, they're just telling you that to freak you out. So the first thing they do is they give us the percentages of each of the elements, and they give us its molar mass. So the very first part you're going to do is do a molecular formula like we did in regular honors chem. So the big thing with this is just to not freak out and to remember what to do. So remember, there's that little rhyme, and it says percent to mass, mass to moles, divide by small, multiply till whole. So what you want to do, the first step is percent to mass. So if it says 12.14%, what you want to think of is 12.14 grams, and so on and so forth. So the first step I do here is I did percent to mass, and then I turn my mass into moles, and that's just a mole conversion. So I looked up each of my molar masses, or carbon, oxygen, and chlorine. So first step is to go percent to mass. Second step is to convert those masses into moles. So you're going to get these answers here of moles of each of your compounds. Then you divide by small. So you look at all your moles, and you divide by the smallest one, which in this case, the two of them are the same and they're the smallest. So you divide by it, and you find that the ratio is a 1 carbon, 1 oxygen to 2 chlorines. And the last step is you would multiply until whole if they were not whole numbers. So like if it was 1.5, 1 2/3, 1.2, that kind of stuff. But since these are our whole numbers, that's your ratio. So your empirical formula is right here, which is COCl2. And then what it's asking you for, if you remember, is to find the molecular formula. So what you have to do for molecular formula is check the molar mass. So this guy's mass should be 98.91. When you find it, it is. So in this case, this guy's empirical formula and molecular formula are the same. If it wasn't, what you'd have to do is the empirical formula's molar mass would be less, and you'd have to figure out what number do I have to multiply that empirical formula by to equal the molar mass that's given. So again, this is old honors chem stuff. The biggest thing you have to do is like remember how to do it. But it's not hard, it's just you need to know the steps. So that is part A. Part B and C we're going to go together because we'll just do them together. And a lot of it I've done for you, but you should have drawn the 3 Lewis structures for it. And remember, you're showing all the possibilities. So you may think you know the right one, but what they're asking you to do is show you all the possibilities. So what I did is I did my need available share. I saw I was going to have 4 bonds, which meant that one of these had to have a double bond. So what I did is they asked me for 3 of them. I showed them that the double bond was on each of the different possibilities. So it could be on the chlorine on the left, it could be on the chlorine on the right, or it could be on the oxygen. So that's all they're asking you to do, and I'll come right back to this slide. They just said draw 3 Lewis structures for the molecule that satisfy the octet rule. So they're telling you it's not hypervalent. They're telling you it's not electron deficient. All you have to do is draw them. And then C is figure out which one is the most important. So what I did is, you are welcome to do this, and hopefully you did, but I found the formal charge for each of these guys. So the FC is just formal charge. And then they're asking you to pick the one that would be the best. And in this case, since this has all formal charges of 0, this is clearly the best Lewis structure. And you could say that. Due to the formal charges of all being 0, this is the most stable and expected Lewis structure for this lovely guy. And very last thing is using the average bond enthalpy, which you have back in your notes a little bit, estimate the delta H for it. So what they're saying is you're taking carbon monoxide, you're reacting with chlorine and you're making phosgene. Now people freak out because they're like, oh my god, I don't know what phosgene is. You just figured out what it was. You know it's COCl2. So that's what you're making. So when you write your formula, I have carbon monoxide plus chlorine gas is making phosgene. And then what I did to make my life simpler is, oops, uh-oh, it doesn't like me. Hold on, I'll pause this, and I'll be right back in a second. Okay, so I told you I'd be right back. That was a little weird. I drew my Lewis structures so I know what my bonds look like. The trickiest one's probably the carbon monoxide one. If you're not careful, you wouldn't, if you don't draw your Lewis structures out, you would miss that triple bond, and then you would lose the points for it. So what I did here is I said, okay, I'm going to break a carbon triple bond. I'm going to break a chlorine to chlorine bond, and I'm going to make 2 carbon to chlorines, and I'm going to make 1 carbon to oxygen double bond. And then all I did is I looked them up on my thing, made sure I distributed my negative number, and I get a negative 141 kilojoules per mole of the reaction, which means that this is also exothermic. This is the only math in the bonding chapter. So you want to make sure you do these and are able to practice it.